So the last thing that we need to talk about to finish up with our chemistry notes is just a little bit about naming chemical compounds. So we're going to go into very, very basics. If you ever someday in college or even in high school, you might take chemistry, AP chemistry, or college chemistry. Often they'll spend a lot of time, especially like in organic chemistry, reviewing sort of the rules about how different compounds are named, what the names mean, how you can tell about a molecule or a compound based on its name. We're just going to sort of talk about some very basic things. We won't get into lots of detail. There's lots of other rules, but this will sort of introduce it for you. All right, so oftentimes when we're talking about these metal, non-metal compounds, these relatively simple two-element compounds, they're often named using this convention. Okay, you start with the first element. So for example, NaCl. Okay, so what would the name of that be? So if we look at it, okay, we start by just using the name of the first element. Okay? So the first element, Na, is sodium. So we just use sodium the way it is. This is sodium. It's a metal. It's in here. It's stored under a layer of oil because sodium is extremely reactive. If you have your periodic table out, how many electrons in sodium's outer shell? Picture? Just one. What that means is it's very reactive. It will form compounds with many other things, including oxygen, including water, very quickly. And so to keep it in its pure state here, you basically have to keep it under a layer of oil. Okay? If you put sodium in water, it has like a violent reaction with it. So, pretty dangerous metal.
Violent reaction.
I mean, like fizzes and releases gases, and it can explode.
We should do that one day.
What's that?
We should do that one day.
Yeah, watch it test it out.
All right, chlorine is going to be our second element. So, in the second element, often we will just add IDE to the end. So, even though the element is chlorine, when we're making this metal, non-metal name, we change the ending to I. So sodium chloride is the compound formed when sodium and chlorine make a compound. Chlorine is a deadly gas, okay, used as a poison in World War I. It's very dangerous. It burns one's lungs. So if we take this explosive metal, combine it with this dangerous gas, what do we get?
Something stable.
Just salt, table salt, that you put on your food all the time. So sodium chloride is just salt. So obviously when you take two elements and combine them into a compound, the properties can change radically. That the properties of salt, sodium chloride, are completely different from either sodium and chlorine, which it's made out of. And so that's often the case with these compounds.
Don't people put chlorine in pools?
Yeah, chlorine goes in pools. It's because it kills bacteria, algae, things like that. But you're not putting chlorine gas. You're putting compounds containing chlorine.
If there is like salt water, and salt is equal table salt is sodium and chlorine,
Yeah.
then is there chlorine in the ocean?
Not
Because it's gas.
elemental chlorine.
Okay.
Yeah, it's in compounds
All right.
that give it different properties.
So you said sodium, oxygen before, like what happens if you take it out
If you take a what?
of the sodium out of the
If you just take it out of the oil and leave it exposed to air, it'll like corrode very quickly, like turn color, almost like rusting, almost immediately. So to keep it in like its pure state, you keep it under oil. So often we will use Greek prefixes, okay, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, to tell how many of the atoms there are. Now for sodium chloride, there were just one of each. So we generally don't put a prefix on. We can put a prefix on, but typically it's not. So look at CO2. Again, you start with the name of the first compound, first element, carbon. We have oxygen as the second element, but we change oxygen to what?
oxide.
Oxide. And we can now use a prefix to tell how many oxygen atoms there are.
Oh,
Yeah, so that's where we get carbon dioxide.
Ah.
Now, many of the radicals on the back of your periodic table, many of those have a certain endings to them. Not all, but often they end in ite or ate. Like you have nitrate, you have nitrite. You have phosphate, you have phosphite. Okay? So whenever you see ates and ites, generally it means it's something from the radical chart, and you can look it up on that chart. If you notice, you look at phosphate, compare it to phosphite on your radical chart, what's the difference? What's phosphate?
Phosphate, phosphorus. What's the number?
PO, what is it? PO?
It's PO4, but I'm trying to.
What is phosphite?
Yeah, PO3.
PO3. The ites usually have one less oxygen atom than the ates do. Same thing, nitrate, nitrite, chlorate, chloride. So when you see those endings, you're going to be looking on your radical chart. So yes.
If you have, just looking at the chart, I only see one that ends in IDE, is peroxide. And then why is it para at the start if it's O2?
Per.
Yeah.
So so which one are you talking about?
Peroxide, it's like 5 from the top. It's O2. It has a balance of -2.
Oh, peroxide. I don't know why they put the per there. Good question. Not exactly sure. All right, so let's look at some practice. So we already talked about this one, sodium chloride. What would the name of the second? Raise your hand if you can tell me. What is the name of the second compound there? Ali?
Magnesium oxide.
Yep. Magnesium oxide. How about the next one? Abby?
Magnesium dibromide.
Yep. Dibromide. Yep. Magnesium dibromide. Why did you put di in front of it?
There's two.
Because there's 2 atoms of bromine. All right, how about this next one, Li2S? Ella? Yep, dilithium sulfide. Now we put the prefix in front of the first one. Like dilithium crystals, I didn't get that reference.
Is it a Star Wars reference?
What? Star Trek reference. Oh, some people got it, all right. How about this next one? Kazia? Not quite. How'd you? Sulfates? They're close. That is? Yes, beryllium sulfide. If you look on the back of your table, you'll see SO3 is actually a radical. It's sulfide. So this is beryllium sulfide. How about this next one? Diksha?
Aluminum borate.
Aluminum borate. It's another radical. BO3 is borate. And lastly, Diksha?
Calcium carbonate.
Calcium carbonate. So the shell of many mollusks. All right, any questions about how we name those compounds? What?
Why do we not have
What? Oh, the names? I don't know, they're not proper nouns. All right, let's give that. We got a video in here. I guess we got to fast forward right.
Yay!